Welcome to the Math Record. Today we'll be learning about different types of numbers. This video will cover the first chapter in our Precalculus class. In Precalculus and math in general, there are multiple math syntax which mathematicians use to refer to different types of operations. If you want to learn more about math symbols, visit the Wikipedia link below. But today we will only be learning about different types of numbers. Here is a chart of how different numbers are categorized. If an oval is inside another oval, that means that group of numbers is also part of those numbers. For example, that means all natural numbers are also whole numbers, and all whole numbers are all integers. But for example, all whole numbers would not be natural numbers. Only some of them. I'll explain further on in the video. Let's begin with natural numbers and work our way up. Natural numbers are any counting numbers. So if you could count it with your hands, basically that's basically going to be a natural number. That includes numbers 1, 2, 3, 4, 5, and etc. You see the pattern? Those are all natural numbers. Natural. Whole numbers are just 0, 1, 2, 3, 4, 5, etc. The difference between whole numbers and natural numbers is that whole numbers include 0. That's basically the only difference. Because there's a special property about 0. I'm not gonna explain it in this video, but it's not positive or negative. So it's hard. And some other reasons that make it why they want to be categorized into like one of these numbers. It's just based on operations, so you really don't need to know it. But what you really need to know is that whole numbers include natural numbers and 0. That's basically it. Integers are both positive and negative versions of natural numbers, and including 0. So numbers like -3, -2, -1, 0, 1, 2, and 3, etc. as it gets higher, or like etc. as it gets lower, are all like integers. But you also must be able to count them with your fingers. So you can't use decimals like -2.5. Those are not integers. Integers are you could count it with your hands and you could go negative. So it's just positive and negative versions are natural numbers and 0. Above integers are rational numbers. Ration These are any numbers that could be written as a ratio, hence the name rational. These numbers include integers, fractions, and decimals. So integers, like the group below it, the circle. Fractions, which is like one form a way to write a ratio. So it's like a number x and a number y. So you could write like 1/2. That's a fraction. And then there is decimals, which is something like 2.5 or like 2.13. These are all like in ratio forms. So those are all rationals. If you could write it as a decimal or like in any kind of ratio, then basically it's going to be a rational group. Outside of rational is irrational numbers. Sorry, let me get this out first. Irrational numbers, this red square here. Irrational numbers are any numbers. Um, sorry. Irrational numbers are any numbers that are like pi or like square root of a number that cannot be simplified. So, you know how like when you try to calculate the perimeter of a circle, you use this formula called 2 pi the radius, which this is the radius and this is the center right here. Pi is not a rational number. it's an irrational number because an irrational number doesn't stop like there's two reasons for a difference between a rational and an irrational. Irrational either could be written as a ratio or it repeats. Basically, you could do the ratio and repeats are basically almost the exact same thing. So imagine so a rational would be like 2.33333 as it and like infinitely threes. That would be rational. Irrational would be something like 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I mean, sorry, not 10. 9, 8, wait, 2, 4, 9, 5, 3, and it keeps on going but has no pattern of like you see all threes. Then there's no repeating. Repeat. Sorry. Then basically it's gonna be irrational because you can't write it as a ratio because there's an infinite way, so the number will be changing constantly. So that's what's the difference between irrational and rational. So numbers like pi, which doesn't repeat the entire time, like if you see like people that are like competing and memorizing digits of pi, then you know why it's like infinite. Like it's not rational because the number is always changing. So it's like 3.1415, 9265, etc. I don't remember that much digits of it. But usually people just use 3.14. Or they use the number e, which is like 2.8 2.18 something. I think it's something with a 2 for sure. So that's basically what it is. Like, so those are like irrational numbers, but like basically simples. Another would be like square root 5, which is which is irrational because you can't take a square root of this number. So like you can't take a square root 6, you can't take a square root 7, you can't take a square root 8. These are all irrational. But you could take a square root 9, which is 3, so this is rational. See, you know what the difference is, basically? You see the pattern? If it could be, like, simplified into a ratio, like an integer, or, like, some kind of fraction, like, if you take, like, square root 9 over 4, that's equal to 3 over 2. So this thing would be rational. Irrationals are that you can't take you can't take a square root out of it, and you can't, and it repeats and it doesn't repeat, but it's like infinite. So that's what irrationals are. Real numbers are any numbers that like doesn't contain I. So I would make it imaginary, basically. So real numbers are anything that could be like in a number line. You ever see like teachers do like 0 and then like 1, 2, 3, and then if it could be put on a number line, then then it's then it's gonna be a real number. So even if you put something even irrational like square root 5 would be uh like 2 point something. So it's gonna be like something around here. So you could put it on the number line. Um Or you could also put like negatives. So you have like -1, so you also put like right here. So you could put those in number lines. So anything in a number line, that's a real number. Anything that's not outside of real numbers are called imaginary numbers. It's not used in the chart, but it's basically outside. So imagine there's a circle right here and it's called imaginary. So basically, imaginary numbers are any numbers that contain the number I. I is equal to square root -1. So we're gonna use a lot of i's in the concept of precalculus. So basically, if you just have like 5i, -i, 2 plus 3i, Like all these are gonna be considered imaginary. All it needs to have is I. The only reason it won't be I would be like it's like 2 plus 0 I. The 0 times I is just 0, so it's just gonna be 2. You know, you get what's the difference? It's just that these have I's. If it has I, it's imaginary. Um, inside the imaginary, let me erase this first. So this is imaginary. The thing that encompasses everything is called complex. Complex numbers are just like any numbers. So the reason they make complex is that they could group together all this circle with imaginary. So you could have like 2 is a complex number, 2 plus 3i is a complex number. Like that's what they want to do. Because like in pre-calc, what they will use complex for is that they use it as a general term to like solve like a bunch of things. So let's say they give you a quadratic function like x squared plus 1, and they ask you for the complex roots. What you have to write is x plus I times x minus I. You won't need to understand why this works, like how this works right now, but we'll explain it later in future videos. So basically, the complex answers would be I and negative I for the quadratic, with the imaginary numbers as answers. So that's why they do it. Or if there's like answers like x plus I times x minus I times x plus 1, then they ask you for the complex answers, it'll be negative 1 I and negative I. Uh, sorry, I. So basically, these would be the answers. But if they only ask for the real answers and not the complex answers, then you only write negative 1. See? That's why learning your different type of numbers is important pre-calculus, because they will be asking about specific terms for specific type of numbers. You won't really need to memorize everything, but what you need to know is that you just get the basic idea how it works. Okay, let's review. Natural numbers are any numbers that you could count with your hands. So naturals, you could count. So whole numbers are 0 plus the counting numbers. Integers are just positive and negative versions of the counting numbers with the 0 and 0. That's what it is. Rational numbers are any numbers that could be written as a ratio. That's what it is. Real numbers, real, are any numbers that could be on a number line. So if this could be on the number line, then it's gonna be a real number. I mean, yeah. Irrational numbers are any numbers that are not rational. So if it's not rational, then it's irrational. So like pi and square roots. Those are like the probably only reasons there, or like e. Um, then there is the imaginary numbers. Imaginary numbers just have to have I. They just have to have I. And complex numbers are just everything. Complex numbers are just anything. Well, today we learned about different types of numbers. Thanks for watching the video, and I'll see you at the next math record.